Second lecture of video lecture series of control system and components. So in this lecture we'll study about transfer function. But before going to that, on the introductory remark, I want to say that in control system engineering, when it comes to the control system analysis, it exactly says that it is a process of evaluating and understanding the behavior or performance of a system, which is initially designed to regulate and influence another system. Now, in the process of this analysis, we understand how a system behaves with variety of inputs, whether the system is stable or not, and whether out of designing that system we are able to achieve our goals or not. So this is all coming under the analysis of a control system. Now, when we go for analysis of control system, one entity plays a major role, that is the characteristics equation. And that characteristics equation that is derived from another entity that is called as transfer function, which is a major entity. Now, with the help of that transfer function, we could able to analyze a control system, be it a time domain analysis or frequency domain analysis. As you all know, time domain analysis is the study of behavior of a system to particularly certain kind of input test signal, that is unit step, ramp, and impulse and parabolic. But when an input signal is specifically a sinusoidal signal, that would become a sinusoidal or frequency domain analysis. Now let us move to the lecture 2. Here in the lecture of this transfer function, we will study about the concept of transfer function, what exactly the properties and what are the advantages and disadvantages, how poles and zeros can be derived from the transfer function, and how the poles and zeros can be located over the AS plane, which is the complex frequency plane. Now, transfer function, by its definition, it is the ratio of Laplace transform of output to the Laplace transform of input, keeping the initial conditions 0. Now, having the system variables at initially in 0 condition, if we could able to get the ratio of output to input in frequency domain, that will give us the transfer function. But mind it requires certain condition that transfer function can only be determined for linear time invariant system. That means a system must be linear and that system must time invariant in nature. So the transfer function cannot be determined for nonlinear and time variant system. Okay. So as it is written over here, the transfer function of the system is mathematical expression that relates the output of the system to its input, assuming zero initial condition. Zero initial condition means system variables are in zero. That means input, output, intermediate variables, they are at zero condition before applying the input. So the transfer function as it is written over here, if that is denoted by Ts, where S is the variable, which is complex frequency, that is nothing but the ratio of Ys to Xs, Ys which is the Laplace transform of output, and Xs is the Laplace transform of input, that is written over here. S is the complex frequency variable from the Laplace transform, and Xs and Ys are the Laplace transform of the input and output signals respectively. Here, two conditions are there. As I said, the system must be linear and time invariant in nature, and the initial conditions must be zero for deriving the Laplace transform. The concept of transfer function further says that it simplifies the analysis of complex system using algebraic method. Which one? The transfer function. It exactly not give importance to system representation in differential equation manner. It rather simplifies our task by converting a differential equation into your algebraic sum form. So, what exactly transfer function helps us? It helps us in studying the stability of a control system. It helps us studying the steady state and transient uh, response or behavior of a system. I mean, when a system, exactly in practical case, when we study the response or output of a system for a particular input, be it in time domain or frequency domain,
The output that that is provided by the system has two parts. One is the transient part, other in the steady state part. So before attaining the 100% level, the output of a particular system that moves to the transient condition. That means it oscillates. It's move into variable condition before going to the stable condition. That initial part where the output fluctuates around its final value, that portion is called as transient portion. So if you want to study the behavior of a system during the transient time, that also, and the behavior of a system during the steady state time, that also requires the transfer function as an entity. As I said, frequency response analysis, that means to study and understand the behavior of a control system, particularly for sinusoidal signal. And it helps us in designing the feedback system. Okay, so these are the things that is get uh, done by deriving the transfer function. Now, properties of transfer function, as I have already told, that it is can only be related to linear time invariant system. That means you can only able to determine the transfer function of a linear time invariant system. So it uses Laplace transformation method, simplifies differential equation into algebraic form, as I said. So means when it comes to analyze a control system in analytical method, there are various type of analysis method, that is graphical analysis method and mathematical analysis method. In mathematical analysis method, if the mathematical expression is there in equation form, differential equation form, then it would becomes difficult to find out the result. Rather, if we have the transfer function in algebraic sum manner, then it would becomes easier to apply the Laplace transformation method and Laplace inverse Laplace transformation method. That would means make the analysis bit more easier to us. So the properties of transfer function is that it is also useful for stability and frequency analysis of a control system, whether system is stable or not. That is called as stability analysis. Advantages and disadvantages. Various advantages are there. First advantage is simplifies analysis using algebraic method, as transfer function is represented in algebraic sum method. So it is very easy to simplify the expressions. Helps determine the system stability. From the transfer function, we could able to determine the poles and zero roots of the transfer function. Locating those roots of transfer function over the S plane or complex frequency plane, we could able to determine the stability of the system, that we'll discuss later on. It is easy to relate the input and output in frequency domain. So it also helps in finding out the relation between the inputs and outputs. Okay. Now disadvantage is that it is not applicable for nonlinear system, even time variable systems also. So no information about the internal state of the system, as it is said that the initial condition is 0. So we do not have any information about the input variable, output variable and the system variable. Along with that, when we are going to analyze the system using transfer function, we could able to get the information about the input and output only, not about the intermediate variables. That is the things. Initial condition must be 0. It is repeatedly I have told. Now let us move to finding out the poles and zeros of from the transfer function, which is very much useful in determining the stability of a control system. Now zeros, how it can be derived? It can be derived by solving the expression of transfer function by taking the numerator part. So if you take the numerator part and if you take equalize that to 0, the roots, those we will get out of that, those would becomes the 0. That means for those values of s, the value of transfer function becomes 0. That's why that is those roots are called as 0. Okay. Now another type of roots that we can derive from the transfer function by taking the denominator part. If we take the denominator part and equalize that to 0 and solve that, then also we will be able to get certain values of s, that complex frequency. For those values of s, If we put those values over the expression of transfer function, then the transfer function's value becomes infinity. So poles are nothing but poles are the root of the transfer function for whom the value of transfer function becomes infinity. Okay. Now after deriving those poles and zeros, we need to look at those over the S plane that we will discuss in the next slide. Here is an example. Here the transfer function is given as s plus 2 by s plus 1 whole into s plus 3. So to determine the finding out the zeros, we need to take the numerator part. Here at the numerator part, s plus 2 is there. I have taken s plus 2, equalize that to 0. If s plus 2 becomes 0, then s becomes minus 2. So 0 comes at minus 2. Similarly, to find out poles, we need to take the denominator part. Here the denominator part has two terms. One is s plus 1, other is s plus 3. If I will take the denominator part, equalize that to 0, then s plus 1 whole into s plus 3 becomes 0. That means s plus 1 is equal to 0 or s plus 3 is equal to 0. If I will take s plus 1 is equal to 0, then s becomes minus 1. If I will take s plus 3 equal to 0, then s would come as minus 3. So minus 1 and minus 3, they are the two poles. Okay. Now after finding out these roots, one is 0 and two poles or zeros and poles, we need to represent those poles and zeros over the S plane. S is the complex frequency. Okay. So when to represent the S plane poles and zeros over the S plane, we need to take the real part along the x-axis and imaginary part along the y-axis. And these values of S, that means these roots, that means the poles and zeros, they also sometimes come as many a times comes in complex form, and sometimes they are having either real part only or the imaginary part. In that case, poles and zeros, they would lie upon the x-axis if that is represented by only real part. Okay, and if that is represented by only imaginary part, in that case the roots they lie over the y-axis. Okay. Now over the S plane, the complex plane with the real and imaginary axis, we denote the poles as cross and zeros as zeros. Okay. Now after locating the poles and zeros over the S plane, we need to find out where the poles and zeros are lying. Okay. Now if you look over the S plane, there are three regions. One region is the region situated left hand side to the imaginary axis. Another region is the region that is situated right hand side of the imaginary axis. Okay. Now if and the in between region, that means the region over the imaginary axis. So there are three regions. So if roots of the transfer function, that means be it pole or zero, if they are situated, all the roots are situated towards the left hand side of the imaginary axis, then in that case we can conclude that the system is stable in nature. Okay. If poles and zero they lie over the right hand side of the S plane or imaginary axis, then the system becomes unstable. And for marginally stable condition, poles and zero they lie over the imaginary axis. Now let's say we are having a 6 number or 5 number of poles and zeros all total. So out of those 5 number of poles and zeros all total, 4 number of poles and zeros they lie towards the left hand side of the imaginary axis, and one of the pole or zero that lies over the right hand side of the imaginary axis. So in that case what would happen? For that pole or zero only the system becomes unstable. Rest 4 number of stable pole and zero they lies over the left hand side. But as there is one unstable pole, so due to that unstable presence of that unstable pole, the whole system becomes unstable. Similarly, how many number of roots means poles and zero they lies over the left hand side of the AS plane? If only a single pole or zero lies over the imaginary axis, for that position, for that pole or zero, the system becomes marginally stable. It is written over here. For system to be stable, poles must lie over the left hand side. So in conclusion, in today's discussion, we can say that for transfer function are powerful tools for linear time invariant systems to be studied or analyzed. Poles and zeros can be determined from the transfer function. They helps in visualizing the poles and zeros in over the S plane, which would be helpful for system designing. So thank you for all these things, and we will discuss about the normal type of transfer function and components of control system in the next class. Thank you.